Welcome everyone. This is hands-on on gestures, part A. We will talk about a simple click listeners that are equipped in Android, and at the same time, let me make sure that okay. At the same time, we will program our own gestures in terms of double tap, triple tap, and maybe swiping left and right and up and down. In all of these, we're going to use the core Android listener or Android on touch interface so that we can program these gestures. So at the beginning, we need to know that at the for to identify any gesture, you need to gather information about the touch, about the duration of time, number of touch to the screen, and afterwards you need to make some computation and identify what kind of gesture do you have. So typically in gathering information, you need to gather some counter, how many time the finger touched the screen. Also, you need to see, for example, where in the screen you have touched. And we will talk more about the details of the information that Android provides. At the beginning, we'll look at some default or already defined listeners, which is the on-click listener and the on-long-click listener. So on-click listener is just a listener or interface that has own method called on-click, and basically you can attach some handler, simple handler to the button to any view, and what you want exactly to do here. On long click listener is something that when you touch something and hold it for a while, or long press, sometimes they call it. In both cases, you can assign both listener to the same view, like such as button. However, you need to pay attention to the fact that a long click listener or a long click is the same, or it's implying a click. So what happens if you have two listeners attached to the same button? One of them is long click listener and another one is click listener. So let me give you an example here. So I have this simple UI where I have a swipe and two buttons. Let's look at the first one, try to click and long click on the same button. And basically here, what I'm doing is I'm taking the text view here, text view 1, and I'm assigning two listeners. The first listener is on click listener, the second one on long click listener. And basically what I'm doing is I'm just doing toast. If I tap on it, I say just clicked. If I long tap, I just say long clicked. And if I run this, let me run it and show you how does it go. You will see that the result will be very simple as expected. So there will be a toast when you tap on the view, text view, and when you long click, it will be another toast. But you will see that something different will happen. Let's check. Now, if here I will just click, and what you will have just click, which is exactly what's going on here. Now, what if I long click here? I long click, say long click, and also he triggers just clicked. This indication that the long click is implying the click, or the long click listener is executed and the click listener also is executed. Now, if you want this behavior to change, notice that there's a return type or return value here called return false on the on long click listener. This indicates that if it happens that other listeners are interested in this view, let them do it. And in this case, you'll see that in this view, there are two listeners interested. The one was long click listener and the second one click listener. Now, if you in the long click listener, you know that there might be a possibility that there's a click listener for this view. So if you return false, that means keep going and handle other listeners. Okay, listeners. Now, if you return true, that means no, this event has to be consumed. So it basically means consume the event, and no more handling from other listeners. And now I'm returning true. As you can see, if I run again, what will happen is that long click listener now only the toast for long clicked will be displayed when I long click on the view. Okay, let's see. It's running now. Okay. It's taking some time. Okay. Okay, so here gesture demo. Now if I click, I will get just clicked as normal. Now if I long click now, long clicked, and that's it. You see? So now we learn how can we allow other listeners to continue handling whatever event on the view, and how can we prevent that. So this, the retain type from the on-click listener method, or the on-click listener method will decide that. Okay, so this is the first thing we learn. The second thing is to program other kind of gestures. We need to know or to study the on-touch listener, which is the core interface for gesture detection in Android. And basically this listener or this interface has only one method called onTouch. And the onTouch has two parameters. The first parameter is the view that has been touched. And the second parameter is the motion event that has been detected. And motion event will hold all kind of information about the touch to the view on the device or on the screen. So the motion event is basically Android or the screen detector or the hardware will provide you with different kind of information that you can maybe rationale and logic create based on the logic to identify the detection or the gesture. So if you look here, the motion event, your program will given different kind of information depending on kind of event happening. So action down indicate that the finger has touched the device. So you'll be told about that. So the on touch, this method, the on touch method will be called with action, and this action could be action down, which means beginning of the touch, action up, which indicate the end of the touch. These are the main two kind of actions that will be provided, but there are others. Another important one is action move to indicate dragging. So three main things that you can check, and based on some information you gather and you compute and rationale to calculate and compute what kind of gestures do you know. The rest we're not gonna look at them, hovering and hovering, so we'll focus on those three. Again, the typical way of creating your gestures is to implement the on-touch listener and write your own on-touch by specifying what is the current action. Is it touch down or action down, which means touch down, or action up, touch up, or some kind of scrolling while you are moving your finger on the device or in the screen. And you gather all kind of information in the listener, and that listener will decide what you are doing. The first thing you're gonna do is how can we, for example, program double taps, for example, or triple taps. I guess more than triple taps is gonna be difficult for us. But double tap, it's something appealing, and triple also. We'll see how can we do that. So the algorithm is here. Basically, the idea is we can define a timer, and when we do touchdown or action down, we start the timer, and afterwards we can do calculating how many another touch within that specific time limit, which is could be less than a second or 700 milliseconds, up to you. With a counter at the end of the timer, we can say, okay, handle or check how many taps has happened, and based on that, we can define our listener to detect double tap or triple tap or also single tap, by the way. So basically, what we need to do is we need to specify. We need to set. Let's say, okay, we need to set a timer. Let's say this timer duration of time, and during that we need to count how many action down happened during that. Of course, we can have a counter for action down or action up, but typically action down is the one. Now, every time there's action down, we increment the counter, and based on that, at the end of the timer, we can decide based on the how many what is the value of the counter. Is it 1, which means single tap, 2 means double tap, 3 means triple tap, and I don't think 4 is gonna happen. So this is the simple logic for capturing double tap, triple tap, and so on and so forth. Let's look at the code and see how it's working. Okay, this is, as you can see, I create my own listener or my own gestures, number of tab listener, and it's implementing the on touch. And as you can see, I have a counter here, and also I have starting and ending tab. Of course, ending time. So I'm capturing the starting and the ending time for the timer, so that the timer so that I can keep track of the time duration between the time where you touch the screen and the previous one, the end of the time or the last time you touch the screen. Of course, I'm using these two to identify the duration of time of the touch or number of touch within this duration. So if you look here, I am looking at the action down, and I have this logic here. Basically, once I have action down, which means the user has just touched the screen. So I get the time. The start time will be initialized, as you can see here. Now here, I just want to make sure that this touch is the first one, which means, of course, while the user is working on the screen, he might touch the screen several times. So I want to make sure that this is really the starting point of the touch, not a touch that are separate from current one long time ago. So to know that, I just say start time minus end time greater than 300 milliseconds. This indicates that this is beginning of the touch or of tapping, let's say. This is the beginning of tapping, okay? So since I identified the beginning of the tapping, I set the tab 0 and I start a thread where basically I am sleeping for 400 milliseconds. And when the thread is up or it's wake up, I call handle tabs, which is, by the way, this class is abstract, and this is the abstract method that is defined here, abstract. This method will be used by the developer. He will decide what he's gonna do with second double tap, triple tap, and so on and so forth. Okay, so this condition indicates that whether this is the beginning of the tab or not. And as you can see, we subtract start time minus end time. It has to be bigger than a certain amount of time. If I go to here, you notice that if you talk about the timer here, we are subtracting this action down versus the last action up previously. If this duration of time is very large, that means this one is, I should start counting from the beginning. Okay, that's why. But if they are not that much apart, that means they are belonging to the same tab. Okay. Now this is the action tab. As you can see here, every time you start the action, you just say tabs 0, you initialize the counter. Now when are you going to increment the counter? You increment it when you action up. So every time you leave your finger from the screen, it will untouch the screen. That moment you increment the counter and you set the end time again. Now if this happened very fast, less than 300 milliseconds, every time you will see that the logic comes here. So the logic comes, for example, the logic comes here, and after that return true. You don't initialize. Right away, you untouch and you come here. So you increment the number of tabs, as you can see here. So this is my number of listeners. Let's try it. How can we use it? Basically, I am using it like this. It's very simple. I am doing, for example, a text view, okay, and I am attaching to the text view my number of tabs listener, and this is the implementation of the handle. If you look back here, this is the method which is handle tabs that the programmer will utilize, because in the handle tabs I can check how many tabs are there. If it's 1, I can do something. If it's 2, I can do something because it's double tab. If it's 3, I can do something else. And as you can see here, I am overriding this method, which is handle tabs, but I am using the notation as you can see here. If you look here, it says handle tabs, as you can see here. So I'm checking the tabs, the variable inside the class. If it's 1, I'm just gonna go and say show a toss saying 1 tab. If it's 2, it will say 2, and so on and so forth. Of course, I'm saying 4, it's difficult to have 4. 3 maybe, but 4 is difficult. Okay. Now, if I run, let's run and see what's going on, what will happen here. You will see basically the first one is the first text here, or text view, will detect long versus regular click. The second one will detect the number of tabs, and it will give you a way to handle what you want to do in each tab. And let's see how does it go. Okay. So here's the second one, the green one. If I click one click, you'll see 1 tab. Okay. If I click twice, you see 2 tabs. Now I will try my best to do 3. Didn't work. So let's see 3. Now 3 it worked. 4, it's really hard. I don't know how 3 it's again. But as you can see, this way you handle that. One last thing here you need to pay attention is that when I override, or when I implement the method handle tabs, notice that here I am putting I'm using a handler. I am posting the toast inside the handler. And this is very important because notice here that I am calling this handle tabs inside the thread. So this is not the UI thread. Because of that, you have to schedule the task in a runnable inside the UI thread. And you should not access the UI, whether it's a toast or anything else, through directly from another thread. I am here in a thread, timer thread, which will be, when it's finished, it will call handle tabs, which is defined here, as you can see. But this code will be run within the boundary of the other thread or working thread, not the UI thread. That's why I'm putting handler post. I am doing that. If you don't do handler post, most probably your program will crash. Okay. Now, The second thing we will look at is how can we do swipe left and swipe right. And swiping is a kind of a gesture where you need to specify a very quick and swift movement of your finger to the left, to the right, up and down. And from the logic, how can you accumulate enough information to decide that? Basically, you need to see the location or the X and Y, the point where you touched. And most probably when you lift your finger, the touch will be a little bit shifted or displaced either to the right, to the left, or up and down, depending on the touch itself. So the kind of information that we need to keep track of is what is the point of touch, what is the point when action up, which is mean untouched, which is you lift your finger. Based on this information, X and Y, you decide displacement, the difference in X and Y, and you see whether the displacement was in X direction, horizontal, which means left and right, or it's the vertical direction, which is means up and right, up and down gestures. Of course, we can add additional information where we can rationale about the speed of the touch. So we can decide that the swiping should be quick enough so that we can consider it or detect it as a touch. Let's look at the class that is used for that. Again, this class is a little bit more complicated. It's abstract class of type that implement also the on-touch listener. And I'm having a lot of things that like convenient for me because I define it once and I can use it all over. So I define constant about what kind of touch or swiping. Is it left or is it right? Is it up or down? For that also I have one integer that decide the kind of touch which is here. So this swipe direction will be it will save or keep track of the current touch. Was it a current swipe? Is it up, down, left, or right? Of course, I can have some threshold about how speed or the minimum velocity and distance that happens. So I'm putting here the minimum velocity 180, and the minimum distance should be shouldn't be a drag, by the way. It should be very small amount of touch. The displacement of the finger on the screen shouldn't be that much, which is 50, only 50, the difference between that. Let's look at, of course, I have the type of touch here where it tells me it's just left or up, but let's look at the logic here. The on touch, this is the method that will decide that. Now, again, we need to keep track of the point where we touch the screen, which is here. So here we are deciding get X and get Y. It will tell us where in the screen the point X and Y. And I am saving that in down X and down Y. This is the point of touch. Of course, I'm defining that here. And this is just internal for the class. Now, for the sake of speed, also you can record the timing so that you can, because velocity or speed is distance divided by the time. So I also record the time of touch. Now, this is the moment of touching the screen. So what we do is we record the location and we record the time. Now, the second part here, when you lift your finger from the screen, and here we keep track of the same thing. We keep track of now, rather than keeping track of the X or the location, we do the displacement. This is what delta X or displacement. Okay. We calculate displacement at X and also delta Y, which means displacement of Y. Why do we do that? Because at any time we need to decide whether the swipe was left or right, but it could be both. But we need to decide whether it's more left than or more horizontal than vertical or vice versa. So we calculate the difference in the displacement here. Also, we can calculate, as you can see, the velocity. Now we calculate distance divided by the delta time. Of course, delta time is the current time minus the downtown, which was kept track of here in the when we make the touch. Now all this information, the displacement in x, displacement of y, and the velocity in x and y, we can check now whether that touch was up or down or left or right. Now first, if we want to decide whether it's left or right, we compare the displacement in x direction and the displacement in y direction, and notice that it could be in negative and positive because we are subtracting some points. So if the displacement absolute value of the x here, it means that it is horizontal. The displacement in x is more than y, that means this is horizontal. Otherwise, it means this is vertical. So in horizontal, let's talk about horizontal, the same logic applied to vertical. In a horizontal, that means either the swipe is left or right. That's why here we say either left or right. But how can we know whether left or right? Basically, you can tell that if the displacement is positive, that means it's swipe right. That because it means that the sweep went this direction. And if you do the other way, it means it's sweep, the swipe was in left direction. I don't have okay. If you think about it a little bit, let me yeah, if you think about it, it makes a lot of sense that the direction in the right, if you swipe your finger to the right, normally that means on the positive side. Yeah, you start and you end your finger to the positive side of x. That means swiping right indicates that displacement is positive, and otherwise gonna be negative, which means left. On the same token, you can apply that vertical up versus down. But you need to pay attention here is the coordinate in the screen is at the top left. This is the origin. And the x is as normal, but the y is tilted to the opposite direction. So the y in the y direction is positive downward. When you go down, the y-axis is increasing, and that's why when you swipe to the down, it's gonna be positive, as you can see here. Okay, this is why, because traditionally in the coordinate and or the graphics and computer science, and the screen of the device, normally the origin is 0, 0 is located at the top left, top upper left. And the x coordinate is as normal, but the y coordinate is the opposite, which means the positive direction is downward and the negative direction is upward. Now, as you can see here, you implement the handle swipe to do that. And if you look at an example here, let me make this okay. Okay. So the other one is try to, again, we have an image view, and in the image view, I'm trying to decide how did I swipe it to the left, to the right. And basically I am getting the swipe type and say if it's swipe up, that means I will display up. If it's down, I'll be down. Of course, typically you don't need all of this on one view. Normally you need just to define left or right or versus up or down. But this is very powerful. You can decide your own. You can decide or change the logic based on your needs. And if you look here, changing the logic here, I am also incorporating how much velocity and how much displacements going on. Of course, this will make things very not complicated, but this very robust to identify how fast, if you decide how fast is the swipe versus the amount of drag on the screen. So let's look how does it work. So this is an image. Now I can click and nothing will happen. Now if I hold and just go to the left, you'll see that swipe left. If I just hold and go to the right, you'll see right. If I go up, you'll see swipe up. If I say down, it will be swipe down. Now I can go to the diagonal like this, and I don't know it's tell me left, which means the displacement in the horizontal or the X direction is more than vertical. I can do a little bit like this and told me up, even though it's left up, but it decided that up based on the touch and the direction and the speed. Okay, so this is it for the swipe. So this is it for this lesson. I will be back on how can we do a gesture listener or gesture detector that is built in on Java in Android, and we'll have some hands-on. Thank you very much. I will make everything available in terms of examples on the same in the description part.